Okay, so in your project, how AWS Jenkins pipeline and all has been used? Do you have any idea?
Yeah, in my project, I have used it. So, uh, AWS is basically have various aspects like it has EC2 instances, it has S3 buckets, and some code deploy is there. So, basically, EC2 instance we use. So we will have various instances over there, and we can deploy various hosts over there and various servers. So Jenkins was also deployed on a dedicated EC2 instance with proper security groups configured to allow secure access. And whenever we want, we can like with IP address. If we have various servers, so with IP address we can search, we can start, stop. So all those things we can do. And
So you always start and stop the server?
not always, but yeah, actually, uh, in our company, we have for the cost cutting, they have uh, scheduled some timing like daily. At night they shut it down, and again in the morning we have to restart it manually. So yeah, so for the cost cutting they have done it.
Okay, 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 go on.
Yeah, so yeah, so that is EC2 instance, and then S3 is also crucial for storing build artifacts and logs. So every successful Jenkins build would automatically archive the artifacts to S3 for backup and retrieval process. So that is what AWS part I have worked on. And in Jenkins, like I have implemented Jenkins pipeline using the declarative approach like Jenkins file, which allowed for better readability and version control. So for some time I have taken part in that, but mostly for the code build and packaging we mostly use it. So all these are actually automated process. So whenever we make any changes to code, we push to Git, and Git is automatically linked to the Jenkins. And as soon as we make any push to the Git, so it automatically starts building it, and we can check if the build is successful. It automatically deploys to the staging server. I mean initially. So basically, the combination of AWS service and Jenkins pipeline, like that, enables us to achieve continuous delivery with reduced manual intervention. So we don't have to manually do the things, and it continuously builds and deploys the whatever service we push the code into. So yeah, so that is the advantage of using these.
Okay, okay. Okay, so you have experience on microservices and all, right?
Yeah, I have experience on that.
Okay, so what are these microservices and can you tell me the architecture of it? So when you use that,
Yeah, so yeah, I have experience on microservices architecture. So in microservice setup, the application is divided into a smaller and various loosely coupled services. So each service will be having like kind of, we can say, like one module will be there. So uh, all the modules can be deployed separately, and they will have the separate database, and they can have the separate technology as well. And but we have the another type of architecture called monolithic. So in monolithic, all the modules will be the part of the same project. So we can say like it will be tightly coupled, and if we have to deploy, we have to deploy the whole application in one go. But that is not the case with microservices. So basically, microservices are decentralized and they are scalable. So we also can have the fault tolerance system, like suppose uh, if any microservice is not reachable, then how we can handle that. So histories and all can be used. And yeah, basically, yeah, so these are the uh, architecture of the microservices. And
Okay, see, monolithic application can also be scaled, right? Suppose we have monolithic application with all the modules and in the same project. So if we want, we can scale that as well, right? And we can also perform the load balancing and all, correct? So why you think microservices are more useful despite of having multiple services we have here, right? All the services we have to deploy and we have to continuously monitor. So all these are overheads, right? So how it is more useful than monolithic?
yeah, that is true. That monolithic application can also be scaled by like replicating the entire application across the multiple servers. But still, it has various disadvantages. Why? Because whenever we have to scale, we have to scale the whole application, right? So we cannot scale the only a specific module. So whenever suppose the heavy load comes, so it is not necessary that the load will be on the whole application. It can be only on, let's say, uh, uh, in Amazon or in Flipkart we have a big billion days going on, right? So first of all, user will browse normally more to some different sections, like in clothes or electronics items and all, right? But the payment module will only be triggered less often, right? So there is no need of doing the uh, that kind of those modules, I mean scaling of those modules, instead of if we don't have that much of load. So that is one thing I feel is why microservices are more useful for the case you told. And apart from that, the deployment time will also be faster in case of microservices, because monolithic will have like whole big application it is, right? So even if a small changes we are doing, so we have to redeploy the entire application. But that is not the case of in case of microservices. Whatever the specific changes we have done to a specific module, only that need to be deployed. Okay. And then also apart from that, as I told, that the different technology we can use to different modules. So suppose some different technology can achieve the faster like processing of whatever the service we are requesting, so we can use that as specific technology, maybe .NET, Python or anything. Yeah. And then also the maintenance will be easier. So monolithic application like that become more complex and harder to manage as they grow. But microservices with a smaller code base, they are very much easier to maintain, because each modules are a very small bunch of codes, only a that perform only that specific task. So yeah, so these are the advantages we have.
Okay, coming to Java, so our execution starts from public static void main, right? Now, what will happen if we don't give static? Okay, suppose if we have public void main string args, okay, we don't have a static. So what will happen? How it will behave?
Yeah, if we don't give a static, actually we cannot give it without a static. So because we are not going to prepare any instance or any object. Okay. So without creation of object, we want to run the project. Okay. So if we don't declare main as a static, So the program will, I think, still compile, but it will fail at runtime. So it will throw the error, maybe, I think, no such method error. Yeah.
Okay, what is the difference between abstraction and encapsulation?
Yeah, abstraction is a process of hiding the implementation details and showing only the necessary feature of an object. So, like, suppose we have abstract class, and there we can just simply declare the method. We don't define it. Okay. So that is what is abstraction, and we can achieve 100% abstraction using the uh, interface, but we can achieve the partial abstraction. So abstraction we can achieve using the interface or abstract keyword. So using the interface we can achieve the 100% abstraction, and using the abstract class we can achieve the partial abstraction. So, and encapsulation is nothing but the wrapping of the properties and method into single unit. So encapsulation, for example, we have any bean class or pojo class, right? And there we can have the properties, and its methods can, we can have the getters and setters for that. We can have two string and all, right? So all can work as a single unit. So yeah, so that is what we can say that it is the encapsulation. Yeah.
Okay, so what is the difference between try with resource and try catch block?
Yeah, try with resource, actually that was introduced in Java 7, and it used for hiding the resource that need to be closed after usage. So for example, we suppose we are reading the file, and once the reading is done, then we want to close it. So in that case, so basically it automatically closes the resource after try block is executed, even if suppose any exception also occurs. So there is no need to add separate finally block to close the resource. So that was the improvement done in Java 7. And try catch is like, that is the traditional approach of handling exceptions in Java. So it requires like manual resource closure, typically in finally block we do. So in older version we used to do that. So in that in the finally we used to just check if that any buffer reader is there that is not equal to null, then buffer reader dot close, like that we used to do. Yeah, so this is the difference between these two.
Okay, okay. Okay, so when we should use atomic and when we should use volatile keyword?
Yeah, so atomic and volatile both are used in multi-threading. So we can use volatile whenever we only need visibility uh, uh, guarantee. And so basically volatile ensures that the latest value is read by all threads, but it does not guarantee the atomicity in compound operations. So for example, whenever we write a volatile int counter equal to 0, and whenever suppose we have like public void increment, and then we say like the we are incrementing the counter, so that counter is basically non atomic. So we can use atomic when we need both visibility and atomicity. So we can use atomic whenever the operations like increment, decrement, or compare and set, so all these must be performed atomically. So in that case we can use atomic keyword. So like for example, we have atomic integer, right? Uh, that class is there. So with that whatever the object is there, so with that object we can use the method increment and get. Okay. So here we can use the atomic for that.
Okay, what is synchronized keyword and where and how we use it?
Yeah, synchronized keyword in Java is used to control access to critical sections of code. So, so synchronized keyword is used to ensure that only one thread can execute a block of code or method at a time.
Okay, what is null pointer exception and how can we prevent it?
Yeah, null pointer exception is basically so that comes whenever we try to fetch, suppose any object is there, okay, and that object is already null. So and on top of that, suppose any operation we want to perform or any method is there, then it will throw the null pointer exception. And that, for that we can always check before uh, getting the or performing any operation or any method fetching out of that object. So before that we can just check if that is null and all. So but and also in Java 8 onwards we can use optional to check that. So yeah, so that is what is the null pointer exception.
Okay, okay. Okay, what is the difference between auto boxing and unboxing? Do you know?
Yeah, auto boxing and unboxing is basically the converting the like uh, lower data type or primitive data type to the wrapper classes. So for example, if we have, let's say, int, let's say any number equal to 5, so uh, whenever we assign that number to any integer object, so like integer, the wrapper class, so that is called auto boxing. Okay, then unboxing is like it is automatic conversion of wrapper class back to its corresponding primitive types, so that is what is called unboxing. So again, suppose we initially we have integer, the wrapper class, any like object equal to 10, and again further back to I mean, once suppose we are putting that integer wrapper class object back to the primitive data type, so that we say like that is coming to the uh, like in primitive data type, so that is unboxing.
Okay, so when this auto boxing and unboxing can cause null pointer exception, do you know?
Yeah, that can cause a null pointer exception. So let's say we have a wrapper class, like let's say integer, we have an integer object equal to, if we say null, okay, and then again suppose to primitive type, if we're assigning that that object, and that object has null value, so in that case it will throw the null pointer exception.
Okay, okay. So have you ever found this in your project when this scenario happened? So any real time scenario can you tell?
Yeah, real time means let's say we have any map is there, okay, and that map, suppose we are doing new hash map, okay, and that map has key and value, like key is string and let's say value is integer, okay, integer wrapper class, and the various values has been added, and also there is one value is like the key is, let's say, key 1 and the value is null, okay, and since the value is here integer wrapper class, now suppose if we say map dot get of key 1, okay, and since the value of the key 1 is null in the integer wrapper class, so in that case while this unboxing process, the null pointer exception will happen. So yeah, so this is what is the real time scenario.
Okay, okay. Okay, what is the difference between predicate, function, consumer, supplier?
Yeah, predicate basically that represents the boolean type of value. So whenever suppose we say predicate of any object, okay, and that object dot test, when we say, so it returns the boolean type of result. Okay, and then whenever we have a function, so function that represents a function that takes an argument of type t and that returns of type r. So any function we have, let's say any function object is there, and then that whenever we say object dot apply of any number, so it will just simply return the whatever the number we have. Yeah, okay. Then we have consumer. So consumer is like that represents an operation that takes a single input argument and it returns no result. Okay. So uh, like whenever we have a consumer and then suppose any object is there, okay, and whatever the value it will have, so that object dot accept whenever we will say, so it will simply take the I mean whatever inside the accept. Okay, then supplier is basically that represents a function that takes no argument and it returns the result of type t. So whenever we have supplier of object and that whenever we say that object dot get, so it will just simply give whatever the method it has, so it will return that.
Okay, can we use constructor within an interface?
A constructor, no, we cannot use that.
Okay, and why?
Yeah, because uh, interface are used to define what a class should do, not how it should do. And constructor doing means so we want to do the object instantiation, right? So that we cannot do using interfaces. Okay, so basically interfaces are abstract types, right? So we cannot create an object of an interface. So without object instantiation constructor, like we can say it has like no purpose, right? So that's the reason why we cannot use.
Okay, and how about static methods? Can we use that inside the interface?
Yeah, from Java 8 onwards, yes, we can use default and static methods. Yeah.
Okay, okay. Okay, can you tell me the scenarios when finally block is not executed?
Yeah, so first scenario is system.exit. So suppose we write anywhere system.exit, then it will terminate the program then and there itself. So it won't go to finally. And apart from that, if JVM crashes or we forcefully terminate the program, then also the finally will not execute. So yeah, these are the scenarios.
Okay, what is the difference between error and exception?
Yeah, error and exception both are the like the top level is a throwable, and under that error and exception comes. So error basically we can say like it is kind of non-recoverable situation. So whenever any system related problem happens like stack overflow, and also in that case uh, uh, we say it is an error, so it might be related to JVM and all. The but exception is something like it is a condition that application might want to catch. So it can be of again two types, checked and unchecked exception. So checked exceptions are like output exception, SQL exception. So they all are checked exception, and this happens at compile time. That is what is checked, and unchecked is that happens at runtime. And there are few examples like null pointer, arithmetic exception. So all these comes under the unchecked exception. So yeah, so this is the difference between error and exception.
Okay, so in Spring Boot, what is the purpose of REST controller advice annotation and how it is different from the controller advice?
Yeah, REST controller advice is a specialization of controller advice annotation, we can say, in Spring Boot, similar to how we have a controller and REST controller. So it is specifically used to handle the exceptions and provide consistent error responses from REST APIs. The main difference is that the REST controller advice combines the behavior of controller advice and response body. Okay, so it automatically serializes the response to JSON or XML. While only whenever we have only controller advice, so that is mainly used for rendering the views, like whenever we have MVC application, so in that case we use this. Okay, so REST control advice is more like we use in the RESTful web services, so where response need to be sent as a resource representation, I mean usually through JSON. So if we use suppose REST control advice to handle the exception globally, so it allows us to avoid repeating exception handling logic in individual controllers. So yeah, so that is why we use these two annotations.
Okay. Okay, so how does Spring Boot manages the inbuilt servers, and can we switch it, and how we can switch it if we can?
Yeah, Spring Boot comes with like a default server. So the most commonly used server is like Tomcat will be there, but it also supports other servers as well, like Jetty and all. So the server is embedded within the application jar, so that makes the deployment much simpler since it does not require a separate server setup. So to switch between the servers, suppose if you want, then we can modify pom.xml, or in case of build.gradle. So that file, by excluding the default server, we have the default like exclude keyword, so that we can add, and we can add the required server whichever we want. Okay, so Spring Boot basically automatically adjust the server properties based on the server type, so you can further customize in that like application properties and application.yml file, so we can give the properties and all again further. So yeah.
Okay, okay. What is service discovery? Okay, and how does Spring Boot implement it in microservices?
Yeah, service discovery is a mechanism, we can say, where microservices can dynamically discover and communicate with each other without hard coding the IP address. So we don't have to hard code it. So so the service discovery basically, I mean, dynamically generates the IP address. So in Spring Boot service discovery, like we use the Netflix Eureka. I have used, and in uh, normally in the setup, so the Eureka server acts as a registry where all microservices register themselves and start. Okay, so once registered, other microservices can discover them using the services name, like, and we don't have to hit that specific URL. Okay, so it automatically manages, and based on the availability, it simply provides the whatever the uh, service is available to the calling, any calling service. Okay, so Spring Boot makes it easier with annotations such as, like, we have enable Eureka server, and again on the registry, I mean, on the client side we have at the rate of enable discovery client. Okay, so yeah, so these are the things are about this.
Okay, so how does Spring Cloud Circuit Breaker help in fault tolerance, and how it is different from old hashtricks?
Yeah, Spring Cloud Circuit Breaker, like that, provides an abstraction layer over different circuit breaker implementation. So we have like so fault tolerance. So whenever one service is slow or down, so in that case it helps in fault tolerance. The difference wise, the main difference in older Histrix is that Histrix is now in maintenance mode. Okay, and while a Spring Cloud Circuit Breaker that provides like more flexible and uh, extensible approach by integrating with modern libraries like Resilience 4J and all. So basically, this Resilience 4J is designed for functional programming and that has better integration with Java 8 and above. And this Hystrix was basically a little bit more complex to configure. So yeah, so that's the difference.
Okay, so what is acid and base in database? You know?
Yeah, ACID basically stands for atomicity, consistency, then I stands for isolation, and then D for durability. And again, base is basically available. Then I don't remember the abbreviation for all this, but acid properties are typically used in relational databases where consistency is more prioritized and transactions must be fully completed or rolled back to maintain the consistency. And base is more common in distributed like no SQL database where availability is the more priority and data may be eventually consistent, so that means that it may not be immediately consistent across all nodes but will become consistent over time. So yeah, so that's the difference between these two.
Okay, okay. Okay, do you know what is database sharding?
Database sharding. Yeah, database sharding is the process of prioritizing large data sets across multiple databases to improve scalability and performance. So in this case, instead of storing all data in a single database, so sharding basically that breaks the data into like multiple pieces. Okay, so that can be distributed across the different servers. So sharding basically commonly used when a single database can no longer be handled easily due to like suppose large data volume or the number of requests. So by distributing the data across the different shards, so read and write operation can be processed in parallel, reducing the latency and preventing the bottlenecks. So that just makes the life easier.
Okay, okay.